We're still doing implicit differentiation, but they want us to find a tangent line now. So they're saying basically, now that you know how to do the derivative, let's actually apply it to something. And you know what? This looked like a really cool function. So I wrote some code and I actually plotted it. And you want to know what the plot of this function looks like? Bam. Now this star here is the point that they've asked us for. See this? Pi over 2, pi over 4. I put a star there. I'll bring it down a little bit so you can look at it. This is what these functions look like. Isn't that cool? It should be three-dimensional, but I color-coded it in 2D. So here's your y, and this is your x values, up to like -5 and 5. And because we're using functions and dependence of the function, you can get crazy stuff like this. So we'll see what the tangent line looks like, but I wanted you to see how cool this is. Okay, so with that motivation, let's do some implicit differentiating here and see if we can figure it out. And I'm going to take the derivative, and this is definitely a product rule, right? And what's a product rule? We've done it a million times at this point, but I still always write it u prime v plus v prime u. Now u prime is dy dx. That's exactly what we want. And v is still just regular sine of 2x plus v prime cosine of 2x, chain rule, right? Times 2 cosine 2x. I don't know if you know Nedry from Jurassic Park, but that's exactly who I was channeling there. And then u, so this is going to be a y here, like that. Okay, so here's the first product rule, and that's going to equal the second product rule. Looks like over here, u prime v plus v prime u. U prime, what's the derivative of x? That's 1. And then v is cosine of 2y plus v prime. That would be Bueller. Well, it's going to be a negative sine of 2y. And then chain rule, so it'd be 2 times that. And then x is going to be over here. And before I put the x in there, let's not forget the chain rule, because it's going to be a dy dx here also. Then it's times u, like that. Okay, what have we got? Let's spread this all out. So let's put the dy dx's on one side. That would be sine of 2x here. And I'll just kind of cross off the ones I've already accomplished here. And who's left over here? This mess. So let's bring that over. That's a negative, so we add it to the other side, it would become positive. Plus, is it 2x sine 2y, like that? 2x sine 2y. I think that part's managed. And we'll put the other stuff on the other side. So let's move this guy over. We get negative 2y cosine 2x plus cosine of 2y. Let's see that. That would be 2y cosine 2x and cosine of 2y. So okay, good. So we'll divide that out and we'll get our dy dx, which would normally be the end of the problem compared to the last ones. But we have something else going on here. This is cosine of 2y minus 2y cosine 2x divided by sine of 2x plus 2x sine of 2y. Okay, so there's our derivative. And now we're going to plug this in because we have x and y values. And what I'm going to do is I'm going to do a quick unit circle here. Right, and at pi over 2, that's up here. So that is a cosine of 0 and a sine of 1, because that's the coordinate value. And pi over 4 is going to be here. And that's at, if I remember right, root 2 over 2, root 2 over 2. In case we need to know the sines and cosines of those, because we got a lot going on here. So here's our slope. That's a formula for any slope for any x and y. And remember what that really can produce. I mean, look at this thing. You don't know where we are at the moment, really. Let's plug stuff in. So we're going to need cosine of 2y. What's our y value? Should I write it down here? I'll make a quick copy of it just so that it's not lost. Pi over 2 and pi over 4. That's the coordinate point we're trying to work with. I'm going to draw my little angles here just to remind myself that I'm looking at pi over 2 and pi over 4. But don't worry about it. Okay, so this is going to be cosine of 2y. Y is pi over 4. So that means we want cosine of pi over 2 minus 2y. That's also pi over 2. Cosine of 2x, which is pi, divided by sine of 2x, which is pi, plus pi sine of pi over 2. Okay, so where's pi over 2? Pi over 2 is here. So cosine of pi over 2 is 0. So this is 0. Say 0. I don't really want to write it in a different color yet. 0 minus, what's cosine of pi? That's over here. Cosine of pi. This is coordinate point. I'll use regular ink. That's negative 1, 0. So cosine of pi is negative 1. So that's pi over 2 times negative 1 divided by sine of pi. That's also here. That's 0. That's the y coordinate at pi. Plus pi times what? Sine of pi over 2. Well, that is here. That's 1. So what do we get down to here? We get a positive pi over 2 on top divided by pi. So we'll just put the pi up in here. We'll cancel those out and we get 1/2. This is our dy dx, i.e. the slope of our line. So we're going to get a line. It's equal to y equals 1/2 x plus b. And our y value is pi over 4. And that's equal to 1/2 pi over 2 plus b. Well, pi over 2 and 1/2 makes pi over 4. If I subtract that, we get a b equals 0. So the formula for the tangent line is going to be y equals 1/2 x. And let's see if that tracks. Let's bring our cool graph out again. Oh, I lost it in my clipboard. And it goes just like this. Know what I'm saying? That is the answer to this question. So obviously this is a long and difficult problem, but you're going to get a couple of these on your test and they're going to be worth a big chunk. So pay close attention and walk through it just a little step by step by step. You know?